Hello everybody. If you're watching this video, it's likely that you are taking a physics class. So I want to say good luck. I teach physics. I love physics. I've been teaching physics for over 15 years now. And I've got some tips for you, 6 tips to not just survive physics, but to do well. Okay, tip number 1, taking notes. This is a tip that goes for any class, really, but I tell my students to imagine that as you're taking notes, what you're doing is you're writing a letter to your future self. You know, you're not taking notes just for the sake of writing things down. It does help in the moment to be writing things out. As you're taking the notes, it's helping to put it into your memory, getting more of your senses involved. But you got to think of it this way, that you are telling your future self how to understand this concept, how to do this kind of problem. So make sure when you're taking notes, you always give yourself sufficient information. Okay, and a lot of teachers require taking notes. Really, it's to train you how to take good notes, right? And the whole idea there, again, is that you are writing a letter to your future self. So when you're in class, you're getting a little lazy, just think, make decisions now that your future self will thank you for it. You don't want to, in the future, say to yourself, oh, why didn't I take better notes on this? I don't understand what I did here. You know, take those notes. Tip number 2, pay attention to units. Numbers in physics have units with them. We're talking about the physical world. The numbers are measurements, most of them, right? We have some that are like ratios or something like that. But the numbers have meaning. So it's not just 5, it's 5 meters or 5 seconds, right? Or 5 newtons. Pay attention to what those units are and what they mean and the quantities they're associated with. I have survived whole parts of my physics education by just paying attention to units. And if you know the units, you can actually figure out equations. So for example, force is measured in newtons, that's the standard unit. And a newton is defined as a kilogram meter per second squared. So a newton actually is a bunch of other units together. Okay, and you'll see this later. But if you have a graph, you might have a graph that has force and time. So that's newtons and time. And one of the things that you're going to see that you do is you actually multiply. You take like the area of something, you multiply the height and length. Well, the height, again, is not just a number. It could be in newtons. And if you're multiplying it by the length, it could be in time. Because then you have to memorize, well, what is, in this type of graph, what does it give me when I multiply and I find the area? But if you pay attention to the units, all you need to do is realize that you're taking a newton and multiplying it by a second. Things cancel out, and you end up with the same units then as momentum. So you don't have to memorize anything. Just from paying attention to the units, you can figure out what it is you're supposed to. That's just one example, right? So pay attention to the units. Really cement those into your mind and use them as you're looking at problems. Sometimes you can figure out an equation, what an equation is supposed to be, by looking at the units you have and the units that you want. Tip number 3, try to understand the concepts. So often students will memorize equations, and then when they're looking at a problem, they're looking at what's the information that's given to me, what are the equations I have, can I use this equation to solve, you know, which is okay, you know, and if you have to do that, then that's what you do. But the real goal is to get understanding the concepts. What is it happening, and what does the equation mean? You know, it's not just plugging things into the equation. That equation is the perfect expression of the concept. So you need to know the story behind every equation. Right? So that's tip number 3. Really work to understand the concepts and the meaning, the conceptual meaning behind the equations that you're learning. Tip number 4, draw sketches and diagrams. Even if it's just a simple sketch, a simple diagram, physics, there's so much spatial reasoning that has to happen, right? You're given a situation, there's something happening, something's falling, things are moving. Sometimes you get into places where there are multiple dimensions, right? Balls are flying through the air, whatever the case might be. And what the sketch and the diagram, sketches and diagrams, what they're going to do for you is to help you visualize what's taking place. And it's a way of organizing information. You get a lot of information in a problem, and it's hard to keep it all in your head. Don't try. Just put the pencil on the paper and start drawing it. And maybe that'll help you if you're stuck as you're drawing it and writing out all the information, putting the information into the sketch or the diagram, help you to then realize, oh, this is how I solve this problem. This is what's happening, you know, and then you connect it to the concepts that you have. oh, this is this type of concept. So it's this type of equation that I'm going to use to solve this problem. Okay, and then tip number 5 is related to all of this, using multiple representations. So I've already mentioned sketches, diagrams, graphs, and equations. Those are 4 different things. Now those are all related, right? Those are just all different expressions of the same thing. And so you want to be able to switch between equations and graphs and diagrams and equations, right? So going back and forth and relating all of those things to each other and checking the units, those are all there as problem-solving techniques. And so any particular problem, the diagram might be more helpful than the equation. Sometimes you can figure things out just by putting them together from the diagram. You don't even need the equation. But sometimes you really have to rely on the equation, but you want to have the diagram to support the equation, right? So pay attention to the different representations and work on relating them together, going back and forth between those relations, those ways of expressing things. And then tip number 6, finally, check your answers. Do they make sense? Sometimes we physics teachers, we make up problems and the answers don't make any sense. You know, we get that the velocity of the running person is like 500 meters per second. That's just, we're putting the wrong numbers in. But most of the time, especially problems from textbooks, the answer should kind of make sense. So if you do get an answer where the man is running and you get the answer like 500 meters per second, you think, wait a minute, that doesn't really make sense. You go back and check. Here's a story from a physics class in college. We were taking a test. It was a modern physics, and so we were studying light. And the question on the test was this: if I'm underwater, the professor was writing, right, that's context. So the professor says he's underwater and he's looking out, like he's in a pool, and he's looking out of the pool, out of the water. His wife is standing next to the pool, and his wife is wearing a blue bathing suit. So to him, under the water, you know, with refraction and indices and all this kind of stuff, changing light speed based on a new medium, what color will he see his wife's bathing suit? And all of us in the physics class, he commented later, not a single one of us realized this, we just plugged and chugged. We put the numbers into the equations, we knew what the equations were, and when it came out, based on our because we didn't really understand the concept, we were just plugging in, there was a thing that we hadn't taken into account. But the answer that we got was that the light would be in the non-visible spectrum. It would be in the ultraviolet range, which would mean, now here's the thing, it would mean that the bathing suit would then be invisible. And none of us got it. We were all so engrossed in just the test and the numbers that we realized later, and we looked at each other like, holy crap, we're dumb. You know, why didn't we catch that? But it's because we weren't paying attention to the reality, right? Physics is a description of these measurable quantities in reality and movement and how they relate to each other. Okay, so those are the 6 tips. I recommend them. Good luck. Feel free to ask questions in the comments on this video or other videos. Check out the other content in the channel. So don't forget to like and subscribe, and good luck.